Now, sometimes we have to use properties of logarithms first before we can use that property of equality. Like, for example, on this one, we've got a log base 3 of 4 plus a log base 3 of x plus 5 is equal to a log base 3 of 2x. So on the left side of the equation, I don't just have a single logarithmic expression. So I'm going to start by using my properties of logarithms to put these together. When you have a log plus a log, we could use the product property, which says we can turn that into a single logarithm by multiplying together the two arguments that are there. All right, once I've got it like that, then I can set the the two arguments equal to each other. So I think I'm going to go ahead and distribute this 4 also while I'm at it. So 4 times x plus 5 would be 4x plus 20. And on the right there, I'd have 2x. Okay, so now we're down to simple algebra 1 equation. So I'll just solve it right quick. And I got x equals negative 10 for this one. Now, once again, we do have to make sure that whatever we get does not make any of the arguments of my logarithms something that's not positive. So I'm going back to my original here. My first argument has no x's, so that one's not a problem. This one here, if I put in negative 10 in place of x, and then I add 5 to it, that would make that a negative value, which means negative 10 actually cannot be an answer. And that was the only answer that we had. So on this one, I would have to say that there is no solution. The only one that I had to cross out because it was an apparent solution that didn't actually make the equation true. Okay, another example over here. Again, we do have on the left side, we've got two logarithmic expressions, and on the right side, we have one. So before I can use that property of equality, I do need to put the two that are on the left together using the properties of logarithmic properties that we learned before. Since this one says a log minus a log, the property that we would use is the quotient property. So I could turn this into a single logarithm by taking the quotient of the first argument over the second argument. And not that it matters a lot on this problem, but there's no base listed on this logarithm, so we know that that means that that's a common logarithm. So it's base 10. Again, doesn't matter on this particular problem, but sometimes it does. Okay, so now I've got a log of something equals a log of something, so I can set those somethings equal to each other. Now, in order to solve this equation, I do have an x in the denominator, which is not a good place for it. So I'm going to start by multiplying both sides of this equation by that denominator, by x minus 1. On the left side, the effect of that is it just gives me the numerator only. The denominator cancels. On the right, I need to distribute that 4, so that would give me 4x minus 4. And finally, I'm down to a plain algebra 1 linear equation. So I'm going to go ahead and solve by getting my x's together and getting my numbers together and then dividing by the coefficient of the x. Okay, lastly, before I can declare this a solution, I do have to check to see if it is actually a solution. So if I take 7/2 and I put it back in place of x, I want to make sure that it does not make any of the arguments something that is not positive. So if I put 7/2 in here, 7/2 times 2 is a positive number. And then if I add to that, that's still going to be positive. So this one's okay. If I put 7/2 in here, well, I have to take that then and subtract 1. So as long as 7/2 is bigger than 1, when I subtract 1, it's still going to be positive. 7/2 is 3.5, so it's still larger than 1. So that means this is a good solution. Alrighty, now you have a couple more questions to answer.